Hi everybody, let's go over some announcements related to class number 2 for Engineering Economy. This is the lecture that is intended for Wednesday, the 25th of August. Just as a reminder, our classes are going to be recorded during this first week of class, but then starting with Monday of next week, meaning Monday the 30th of August, we'll be in person in our normal class location, and hopefully we can settle into a good routine when we meet each other face to face. So a couple of announcements. First of all, remember that this homework 0, which is the getting to know you assignment, that one should be uploaded to Blackboard before 5 o'clock on Friday. The next assignment that's going to be on your radar after homework 0, homework 1, which is about interest, that assignment is due before class on Wednesday, September 1st. And so most of the assignments through the semester are going to be due before class, and so since our class starts at 11, that's when the opportunity to submit will close on September 1st. And so make sure that you upload your PDF file to Blackboard before 11 on the 1st. I mentioned in the previous lecture that my expectation this semester is that when you submit your homework, it's a nice clear image that the grader doesn't have any trouble reading. You know, you've got good clear handwriting. It's best if you work out your problems either on just a blank piece of printer paper or on engineering computation paper. And let me show you what that looks like. All right, I've just found a pad of it here in my office. This is engineering computation paper. The thing about this is it is got graph paper on the back of it, and on the front it's blank. And so what that means is that the little squares are just faint enough for you to see that it helps you to draw diagrams straight, and your text is following a nice horizontal path. But then when you turn it into a scan or take a picture of it, those markings don't show up. The squares don't. Just your own writing shows up. So either use blank printer paper or engineering computation paper, but please don't use ordinary lined paper for the assignments you submit, especially when we start doing cash flow diagrams. That's really distracting to use just ordinary notebook paper. So plain paper or engineering computation paper, and you can get that engineering paper at the bookstore or at any kind of office supply store or on Amazon. Okay, so with that said, what we're going to do now is jump into the course material, interest rates and rate of return. This is going to be another one of those classes that was previously recorded in an earlier semester, and so I'll be interacting with the students who were joining virtually during that class meeting, and you may notice some of their questions or my answering some of their questions. Another thing I wanted to mention is that you need to have those in-class exercises printed out, because this is going to be another one of the classes where we go through a couple of problems on the in-class exercise. And what I'd like you to do is pause the recording when I tell the students in that lecture to, solve the first problem in the in-class exercise. You should pause the recording and don't just copy down what my solution was, because obviously you're not going to learn as much if you just copy somebody else's solution as if you engage mentally with the material and you try and solve it, do your best, even maybe speak to a classmate on how did you solve the in-class exercise, and then you can unpause it and compare what you did to my solution. So that's kind of the intention with these in-class exercises. Okay, so if you have any questions about the material, feel free to reach out to me via email, and otherwise enjoy the interest rates and rate of return.
So let me pull that up. We kind of had to rush through the third problem a little bit. Okay, so the third problem was both an exchange rate problem and also an interest problem. And so I did bring up the solution to that one on the screen during our class meeting on Wednesday, but because it was kind of pressed for time, I wanted to see if there were any questions looking at it another time. So just to refresh your memory, what we did was we converted this Icelandic krona that's in the savings account to an equivalent amount in dirhams. And so this first part was finding the exchange rate. So how many dirhams do you get for a certain amount of Icelandic krona? And then the second part of that problem was looking at the interest component. And so what we're looking at today is the original amount that was in the account plus also some interest. So what you can do is you can think of, if we want to find out what was that initial amount, that was at time 0 a year ago, and today is year 1 after a year. And so the amount that we calculated here, 1563 dirhams, that's the amount at year 1, and we're trying to solve for what was the initial amount. And so the initial amount is going to be 1.03, well, 1.03 times the initial amount is how much we've got now. Okay, so I just wanted to give one final opportunity in case anybody had specific questions about this one. Now, some of you may already have checking accounts and savings accounts, and this is old news, but some of you may not have really had a lot of exposure to the world of personal finance. So a checking account is used for the frequent withdrawals that you'd be making on a daily basis. They may issue a debit card. You have access to your money through ATMs or writing checks and online transfers. But a checking account typically isn't going to earn any interest, or if it is, it's almost insultingly low. Like, I think I have an interest-bearing checking account that pays 0.01% interest. So like, if you were going to put thousands of dollars in a bank account like that, you'd get pennies per month in interest. So checking accounts really aren't for earning a return, but they're more just for the keeping up with your expenditures, and it's the place that the money is going in and out. A savings account, on the other hand, typically isn't intended for lots of frequent transactions in a month. And a lot of savings accounts have a limit on the number of transactions that are allowed in a monthly period. So you can't write checks against a savings account, but they do bear interest. Though these days the interest rates that are being paid for savings accounts are extraordinarily low, and they can change at any time. So if you put money into a savings account and you're earning 0.6% interest today, there's no guarantee that you'll earn that same interest rate next month. The bank has the option of changing how much they pay you at any time. Now, when you put money into a savings account, the bank uses that to loan to other people. And as you might expect, they're going to charge those other people a higher percentage for the privilege of using the money than they pay to you. So that's part of the way that the bank makes profit, is the difference between the amount of interest they charge to other people and the amount of interest that they pay to you as the lender. Money market accounts are kind of a hybrid between a checking and a savings account because they're interest bearing and they typically offer a better rate of return than a checking account would. And you can often write checks against a money market account, and they're insured by the FDIC. Maybe some of you have heard about that before, but when you put money into a bank, even if the bank goes out of business, your deposits are protected by an insurance program that's instituted by the federal government, and that's called FDIC. So it's an important thing. A certificate of deposit, or a CD, is an agreement between you and a bank that you're going to leave your funds in the account for a fixed period of time. And during that period of time, the bank isn't allowed to change your interest rate willy-nilly. It's going to stay a fixed, agreed upon interest rate during the deposit period. So there can be CDs that are 3-month CDs, a 6-month CD. There could be CDs that even have 5 or 10 years as the time horizon. But it's a time deposit, and if you withdraw your money early, then generally there's a penalty for taking the funds out too soon. And the reason why the bank is interested to have money like that is that a savings account could be withdrawn at any time, and then the bank may not be able to give you your money if it's invested in someone else's auto loan or mortgage. And so a certificate of deposit is kind of a more stable cushion for them to loan out to other people. And so it reduces the risk that there's going to be a run on the bank that makes it hard for them to pay all of their depositors at once. So sometimes people get confused because they carry plastic in their wallet and they don't understand whether it's a credit card or a debit card. And so a debit card is directly linked to the deposit that you have in your checking account. So when you make a purchase with your debit card, you're spending your money. But when you make a purchase with a credit card, you're taking out a loan and you're spending the bank's money, at least temporarily. Because the bank, when they issue a credit card to someone, they're extending a personal line of credit, which is an ongoing loan. And if you pay the balance in full each month, then you don't have to pay an interest, any fee for the privilege. But if you only pay part of the balance, like if you pay the minimum payment, for instance, or less than the full amount, then there is an interest that's applied, and usually it's a very high interest rate, partly because of the convenience of having a credit card, partly because banks are greedy, but also because it's an unsecured loan, meaning that the bank doesn't take any collateral when they give you a credit card. You're not promising that they can take your house if you don't pay your credit card bill, in the same way that a bank can take your house because the collateral for a mortgage loan is the home itself. And same thing with an automobile. An automobile loan is secured by the value of the car that's being purchased. So understand the difference between debit and credit cards. Now, I've already touched on some of the concepts here related to mortgage and home equity loans, but let me talk about the difference between the two. Now, first of all, in the case of a mortgage loan, it is secured, and that's what allows the interest rates to be much lower than credit card interest rates. And another aspect of the difference between a credit card and a mortgage loan is that a credit card, in theory, and a lot of people in practice just pay it off every month without accruing any fee or interest. A mortgage loan may have a time horizon of 15 or 30 years, or in some cases even longer. And so it has a relatively long repayment duration. In contrast to that, a home equity loan is when a borrower is using their equity, which is the portion of their home's value that they own. So like if you've been buying, if you bought your home 10 years ago and you've been making payments on it to the bank, the home itself is maybe worth $200,000, and it could be that you still owe the bank a certain amount. But the home's value that is yours is how much you still don't owe to the bank, and that's called the equity. So you can borrow against how much of the home's value is yours, and then you could use that loan to do renovations or pay off higher interest rate bills like medical bills, or help finance a child's time in college. So home equity loans are pretty common, and they have a much lower interest rate than a credit card, but generally a higher interest rate for a home equity loan than the original mortgage would be. Okay, so let's pause for a moment. I'm going to pause from talking, and I'd like you to consider the questions that are shown here. I've got a table of interest rates, and then there are some concept questions, and I'd like you to discuss it with the people that you end up with in your breakout room, and then take notes on the paper that you've printed out, because I'll ask a couple of people if they don't mind answering what they put for their response.
Maybe because a savings account consists mostly of money you already own.
Okay, that's good. Other thoughts?
It's fully secured, and you can take money out whenever you want to, and the bank is the people that's paying the interest on that one, not you.
I think that's a really important point. That second one you mentioned is that, when the bank is the one paying the interest, they're going to make the rate low. But when the bank is the one receiving the interest, their incentive is to have that as high as they can. And so they want there to be a big spread between the price they pay to acquire money and the profits they receive for loaning money. So I really appreciate that second point that you mentioned. So, what I had written down for the savings account is because with the savings account, it's the bank that's paying the interest. And then the other factor, of course, is that you also have the ability to withdraw it at any time. And so then that money's not as useful to banks because they can't loan it out for as long. All right. So a CD, a certificate of deposit, is a fixed duration deposit where you have to leave the money in there for a certain time. Now, what about this question? Why might the mortgage rate be higher for a 30-year loan compared to a 15-year loan? So, any thoughts about that? Like why a bank would charge a higher interest rate for the longer duration loan?
Money is worth less later.
What's that, Brett?
Money is worth less later, and they'll
Okay.
get their money slower in 30
All
years.
right. So there's the time value / inflation effect. Very good. Was there did I hear somebody else also who's going to start?
Whenever you have a 15-year loan, oh wait, hold on. Okay, for a 30-year loan, the rate's going to be higher because you're taking longer to pay it off.
Okay. Good. Exactly. Now, part of the reason why is because of risk. You know, whenever a bank is loaning money, they have to think about what are the risks here. There's the risk that the lender won't pay it back. That's one type of risk. But there's another type of risk as well. And another type of risk is, what if the interest rates in society go up after they made the loan? So think about it this way. What if you were the bank? You know, like what if you're going to make a loan to somebody? Like you were going to loan $5,000 to your younger brother. And your younger brother agreed to pay a certain interest rate. But then, because of the economy and the availability of funds and a whole variety of factors, what if suddenly now the interest rates that everybody else is paying has gone up? So you could have loaned it to somebody else at a higher interest rate later, and so you've lost the opportunity to loan it to someone else at the higher rate. So another component of why banks charge more for the longer duration loan is called interest rate risk. And interest rate risk is simply that after the bank makes the loan, what if interest rates go up even further and they're stuck getting a low amount of profit from you when they could have got a higher amount of profit from somebody else. So that's another component of why the mortgage rate's higher on a 30-year loan. So here I'm writing, in 30 years there's a higher risk that the interest rates could go up above the rate charged by the bank. Primarily interest rate risk is what I've identified in that statement there. Now let's see. Why are auto loans higher than mortgage loans? Any thoughts about that?
There's a much higher risk of the car not being there soon rather than else.
What do you mean? Can you go into more detail?
So like if you get in a car wreck, that's probably more likely to happen than your house catching on fire,
I see.
for example.
Okay. So the collateral is at risk because you're right. You know, you don't drive your house around on the interstate, but you do drive your car around. When you take an auto loan, they require you to have insurance on it, but still insurance has a deductible, and so they could still lose some of the value. And cars often depreciate faster than the loan goes down. So like think about it this way. If your insurance is only covering $10,000 worth of value, but you still owe $15,000 on a car that you've bought, then the bank may be worried you're not able to pay off the full amount even when the insurance pays out the value of the car, because the insurance is only going to pay you enough to replace the vehicle. They're not going to pay necessarily the full amount that you still owe to the bank. So auto loans are secured with property that depreciates and might make it more difficult to repossess. Yeah, that's another thing. If a repo man is having to track down your car and go to lots of different places, it's more difficult to know where that asset is compared to a house, which is immovable. And then credit cards. What is it about credit cards that makes them have higher interest rates? The thing that I wanted to point out is that they're unsecured loans. So think about the things that you buy with a credit card. You'd maybe buy a flat screen TV, or you'd maybe buy a burrito at Chipotle, or a tank of gas. And it's going to be more difficult for the bank to repossess those things and get their money back I mean, maybe they'll come into your house and take your furniture and your TV, but even if they do, there's not a great reselling market for that in the same way that there's a pretty efficient reselling market for homes and vehicles. So it's just kind of a nuisance for the bank to try and repossess your personal items. And so essentially it's an unsecured loan where there isn't collateral, and so there's higher risk for the bank. Now that's what this figure is illustrating, is risk. And let me talk about it in detail here. On the horizontal axis is cumulative amount, and what it means is the cumulative amount that a company has borrowed. You can see this is in millions of dollars, so let's assume that it's a company that's borrowing the money and not an individual. Now this vertical axis is the interest rate on an annual basis that the company has to pay for the privilege of borrowing the money. And so what this figure and the curve is showing that, for example, if the company wants to borrow $1 million, they have to pay 10% interest. The company wants to borrow $2 million, they also are paying 10% interest. But now suddenly here at $3 million, if they wanted to borrow $3 million, it looks like the interest rate is a little bit higher than it was before. Maybe that's 11%. And the more that they borrow, the higher the interest rate becomes. So any thoughts on why that might be? Why is it that a bank would start to charge a higher interest rate if a company was taking out a larger loan? And before you answer, let me just mention something, that this is not about the duration of the loan. Let's assume that in every case the loan duration is the same, maybe a 10-year loan. So this interest rate curve is going to exist regardless of the loan's duration. So we're talking about $1 million borrowed for 10 years costs 10%. But $8 million borrowed for 10 years is going to cost maybe 17%. So why is it that a bank would want to charge a higher interest rate for the larger loan amount? Any thoughts?
The risk is higher.
Absolutely right. So what kind of risk is higher? Why is the risk higher? Like what is the risk? What's the bad thing that could happen?
The payer not be able to pay it back.
Okay. Yeah, it's the person who's borrowing the money not being able to pay it back. So why is it more risky? Why is an $8 million loan more risky than a $1 million loan? Like, why is it that the bank is going to see that as more risky?
It's more money that they have to pay back.
Yeah. So, I mean, just think about it. If you're borrowing $8 million, your payment amount is going to be higher. So it's harder to pay the loan if the payment is high. So think about your own self. Like if you wanted to buy a car that was $100,000, let's say you decide you're finally going to do it, you're going to buy that Ferrari that you've always had your eyes on. Your payment for that Ferrari is going to be like $2,000 a month, and maybe you could do it, but maybe not. There's a risk that you just simply may not be able to make the payments. And so in the case of a company, a bank, when they give a loan, they're going to look at the company's customers and how many orders they have on the book. They're going to look at the revenue history for the company, and they're going to get an idea of, like, what's the cash flow like for this company, and they'll have an idea of what kind of payment you can handle based on the sales that the company is doing. And so if the bank begins to feel a little bit worried that maybe the loan is getting close to the limit of what you're able to handle, and they think it's more risky, they're going to want to receive compensation for that risk. And so this curve is about the risk of default. Now this is different from interest rate risk. Interest rate risk is about differences in time. And remember, what we had said in this particular theoretical example is, it's the same duration loan regardless of amount. So this isn't about interest rate risk, this is about default risk. And default is what it's called when a borrower doesn't pay off their debt. It's when they essentially default on the loan. They're not paying the money back. Okay, so let's change gears completely, because I think you probably get the idea there. Are there any questions related to this concept before we move on? Oh, I guess I didn't show you this text here. So the trend is, as the cumulative amount borrowed increases, the risk goes up of a borrower not being able to repay. And since there's more risk, the lender wants a higher rate of return. Okay. All right. Now, I'm just going to throw you in the deep end of the pool here for a few minutes. You've never seen anything like this before. I didn't cover this formula in the lecture, but I'm going to see if you can figure out, based on a couple of hints I've given you, like these bold, the words that are in bold, those are some hints there. I want to see if you, in your groups, can figure out some ways to calculate the future value and calculate the annual interest rate. Now, of course, we'll go over it together, but sometimes it's fun just to see if you can figure out things before you've even gotten any instruction on it. So we're going to give that a try in this. This formula is meant to relate the present amount of money to what will be in the future after interest has been applied. So you borrow $85,000 now. That means P is $85,000. The interest rate is 9.5%. And so you need to change that into decimal form in order to use this formula correctly. And so I is 0.095. And it says that the loan must be repaid in a single lump sum. And what that is a hint for is that you need to use the formula that will allow you to calculate the future value. And fortunately for you, I provided that formula, and here it is. So the question is, what is the amount that you'll owe in the future? So find F if n equals 3. All right. So I hope what you were able to work through with your classmates. Let's see. All right. So you can see the interest rate has been changed to 0.095. We have n equals 3. So substituting that all into the given formula, we find that the future amount, the amount that you owe after the $85,000 is going to have this compounding interest effect, is going to be $111,599.25. So we'll talk more about the details of compound interest later, but I wanted to give you this sneak peek in case you wanted to work a little bit ahead on some of the homework problems. This formula and many others like it allow us to account for the time value of money and the interest that is paid and received when loans are made at the present, and then the funds recovered in the future. So the reason why this bank is going to receive $111,000 as a lump sum in the future is that the money that they gave you now, the $85,000 that you receive now, is more valuable than the dollars that they're going to get back in the future. So they're going to want to be compensated, number one, for the trouble of initiating the loan. Number two, they want profit. But then they also have to take into consideration that the inflationary effect of increasing prices throughout society is driving down the value of every particular dollar. Okay, the second question about your uncle will loan you $3,500 and you'll repay him $4,250 after 4 years. Now this time, let's see, in the problem that I gave you here, it wasn't bold like the P and the F. I didn't give you those same hints on the second problem like I did on the first one, but I bet your quick studies and figured out that this $4,250 is a future amount, so that is F. $4,250 is F. P, the present amount that your uncle is loaning you today, is $3,500, n equals 4, and so then the only unknown in this formula is going to be we need to solve for I. So hopefully you've got an equation solver in your calculator, and if not, you can do this on Excel or iteratively just try a variety of different interest rates until you find the one that gives you the F you know that you should receive. And so if you did go through those calculations and set it up, what we have is on the left-hand side of the equation, the future value, $4,250 is how much you're going to pay back, and the original loan amount was $3,500, and it compounds for 4 years, and so that results in an interest rate of 4.97%. And you can check that. You can put 1.049 to the power of 4, and then multiply it by 3,500, and what you'll get is the $4,250 that we already know is the payment amount. So that's a way to double check the interest rate. So like I said, that's just kind of a sneak peek of things to come. The main thing that you need to be thinking about conceptually and reviewing the textbook readings is just this idea of risk, different types of risk.